It took exactly 7 minutes. So, how are you guys doing today? Good. Do you know about the homework tonight? The homework due tonight, do you remember that? If you haven't done that yet, please upload. And if you didn't do anything yet, you still have till Monday midnight. So the homework will be available until, not Monday, Wednesday midnight. It's due tonight, but if you cannot finish, no problem. It's Wednesday midnight. And if you haven't noticed, I actually posted, let me go back. The question this time, the exact questions without their numbers. So you go to homework tab on Brightspace, scroll down, and you have your homework question 1, 2, and 3. You just have to do these 3, and you are done. Upload in one single PDF file.
7 PDFs?
One single PDF file. Plus it's written here on bold. One single PDF.
Does the system do that?
You should put your name on it. You should. I can see it. I can see your name, but still like. And if you haven't uploaded the second one yet, I'm giving you a chance for this time. I'm going to open the second homework also till Wednesday midnight. Only this time, okay? I noticed a few of you did not upload question 2, homework 2. So if you did not, I'm giving you a chance Wednesday midnight, till Wednesday midnight.
How's the homework graded? Is there partial credit?
Depending on how many questions you are doing. So each question is 1 point. If you skip 1 or 2, you're losing 1 or 2 points. And I really count each one of them. So that's your point-wise grade. And then let's say I'm choosing only 1 question to grade correctly. So I take 1 question, 1 of them from all the questions you do. And if that is correct, you get full point. If that is not correct, you lose 2 points for that. Okay. So I did not grade it 1 and 2 yet because I noticed for 2, many of you did not submit. And also, if you have no idea about our class recording, where they are going, our class recordings are under class recording here. If you click class recording, it says, please subscribe. Below, please subscribe, you see the playlist. You click on the playlist and it will take you to a playlist. Even though we have only 3 classes, but I have almost 6, right? 6 videos. That's because I'm teaching the same section twice. You are section 6. So I have 5 and 6. You are 6. The other class is 5. I'm teaching the same materials, but sometimes I skip solving questions here and I do it in my other class. Sometimes I miss solving questions there and I do it with you guys. So depending on if I don't do anything here, that means I did it with my other class. So for example, the last few questions in our last class, one of them I didn't do here because I did it with my other class and I did the last question with you guys. So whatever you are finding missing in your video, go watch the other one. Probably I did it with my other class. We have only 1 hour, 15 minutes. I'm trying to balance my solution process so that I can give all the solutions to all of you. Okay. What else? The lecture notes. So I actually posted the lecture notes for section 1, 2, and 3. So if you go to pre-lecture notes, under pre-lecture notes, I have the lecture notes from section 1.1 to 1.3 in both Word and PDF file. They do not have any solution. If you want to see the solution, take a look at your notebook, but if you're absent, go watch the recording. Okay? Any question, comments? Now about our exam, even though it's supposed to have exam on September 29, like I said in my syllabus. But I noticed that here, we actually did not cover many classes yet to give you an exam on. So next week, so today is 15, and we are going to have a class on 17, and then we have no class next week at all. Monday, Tuesday, Wednesday, no classes.
Wow.
So I'm going to miss the entire week. So that's why if I give you an exam on 29, obviously you'll forget everything because you're not going to study during your break, right? So that's why we will have a class on 29, but then the next Wednesday we're not going to have any class. So 2 Wednesdays there is no class. Next Monday no class, but the following Monday we have a class. And I don't want to give you the exam on that. So I moved the exam from 29 to October 6th. In that way, my point is to have, I have 1, 2, 3 classes to finish section 1.3. If you finish section 1.3, your exam will be 1.1, 1.2, 1.3. I'll post a review sheet over the break. So on 29, if we can finish 1.3 before that on Wednesday, we'll do a little review on 29. If you cannot, then you're going to finish 1.3 on 29. Okay?
We're only having 2 exams.
2 exams.
So when would our second be theoretical?
At the end of September, October, or at the beginning of November.
2 exams and final.
2 exams and final.
Can we do the 10th?
10 on November.
Why?
Is there any specialty? Okay, we'll see how much you finish in that period, in that month. So in October, we are going to lose 2 classes, 3 classes, but we're going to fill 2 classes. Well, so basically we are going to miss only 1 class on October. Okay, so October 6th your exam, and then we have 2 no Mondays, but then Tuesday is Monday scheduled. Okay, anyway, let's start our 1.2. No, 1.3. Today we're going to do 1.3. So no exam next Monday. Not next Monday. No exam in 2 weeks. Your exam will be 3 weeks. 3 weeks from today. And today we're going to start matrix arithmetic. Means we are going to add, subtract, multiply matrices. We're going to multiply by scalar. The only thing we're not going to do is divide matrices. Because matrix division is not possible. So can that divide? Okay, so matrix. A matrix is a rectangular area of numbers written within brackets, and we use uppercase letter to name them. For example, we have A matrix is this, B matrix is that. They have different size, and every number you see, every variable you're going to see in your matrix, we call them elements. For example, in this matrix, you have 9 elements, and in the B matrix, you have 4 elements. So elements means every single thing you see in your matrix. Now, Hoini mentioned the size. What size your matrix is? The size has another name, order. What's the order of the matrix? Or what's the size of the matrix? It means you have to tell them how many rows you have and how many columns you have in your matrix. So for B, we have 2 rows, 2 columns. So the size of B matrix is 2 by 2. On the other hand, on the left side, we have A matrix, which has 3 rows and 3 columns. So its size is 3 by 3. So when you name your size, you always have to name the number of rows first. How many rows you have by how many columns you have. And we denote that using an X. So if you have M rows and N columns, we say it's M by N. That X symbol is called by. We don't say it's M times X. So you don't say it's M times N. We don't say that. which is M by N. So that X symbol is a multiplication. It's by what by what?
Row by column.
Exactly. Always row by column, never column by row. Always row by column. If you have the row and column the same, means 2 by 2, 3 by 3, 4 by 4, we call them square matrices. Because number of rows and column, they're same, they're squares. And in each matrix, we have each row, we call them row vectors. Each column we call them column vectors. So every row is a row vector, every column is a column vector. If your matrix has only one column, we call them column matrix. If your matrix has only one row, we call them row matrix. So in a matrix, we have so many row vectors, so many column vectors. But if the matrix itself has only one row, we call them row matrix. And if there's only one column, we call it column matrix. Okay? I posted all those notes, so you don't have to write them down. You can simply read them out. Now, I mentioned before that when you name a matrix, we use uppercase letters. So let's say this is a matrix named A. Row-wise, we have 3 to 5, negative 1 and 5. Now in this matrix, we have two row vectors, 3 to 5 and negative 1 and 5. And we have three column vectors. The first column vector is this, the second column vector is 2, 8, the third column vector is 5, 4. So these are column vectors, not matrix, okay? These are column vectors. When we use the vectors in a matrix, we can use lowercase letter. So we have a matrix, it's the name big A, but it has column vectors. A1 means column 1, A2 means column 2, A3 means column 3. So each vector, to represent them, we can use lowercase letter with a subscript. And when you indicate the row vectors, we have to use something special. We have to put the arrow on the top. If you don't put the arrow on the top, it's wrong. Because when you indicate a row matrix, you have to indicate that this is a row matrix. By default, we always work with column. But for column, we don't have to indicate anything. But when you work with row, you must tell us that whatever I have here, it's a row vector. So you have to indicate that with an arrow, means you're going from left to right, it's a row. And here, they use a parenthesis. So they put together all those numbers from your row vector and put comma between them. You don't have to do that. You can simply put vector, the square bracket, 3 space 5, 3 space 2 space 5, and then square bracket. So if you use brackets, you cannot use that comma between them because it's the row vector. The indicator is a row vector in a matrix form. If you don't want to use it in a matrix form, you must do parentheses and comma between them. Personally, I prefer to work with matrix format instead of this comma format and parentheses format. Now, just like in a class, if you want to give the position of a student, we have to name the position. We have to see which row and which column the student is sitting. For example, Origin. What is his position? His position is 1, 2, 3, 4, 5, fifth row, and how many columns? 1, 2, 3, 4, 5, 6, 7. His position is fifth row, 7 column. So same way, if you want to indicate the position of an element in a matrix, you have to tell them which row is this, which column is this. That's the position. So we have a matrix 1, 2, 3, 4. The position of the 1 is row 1, column 1. So we say small a 1, 1. It's like 11, it's 1, 1. What does that mean? It means row 1, column 1 has the number 1. If you want to indicate the position of 2, it's row 1, but column 2. The position of the 2 is 1, 2. And we are using small a because our name is big A. So if your name is big B, we use small b for position. If you have big C for the name, you can use small c for the position. So you can use small letters, but that's for position or for vectors. We cannot use small letter for the name or the name. The same thing, the purple one, 4, its position is second row, second column. So it's a 2, 2. It's not 22. It's 2, 2. Means second row, second column. So you cannot say 11 or 21 or 22 or 21. No, you have to indicate 1, 1, 1, 2, 2, 1, 2, 2. That way. Any question? Okay. Then if you have square matrix, the square matrix, you have a diagonal. That diagonal is called principal diagonal. And the position of each element in the principal diagonal are double numbers. For example, 1, 1, 2, 2, 3, 3, 4, 4. That's the position of your principal diagonal. For example, in 1, 2, 3, 4 matrix, if diagonal is 1, 4, the position for 1 is 1, 1. The position for 2 is 2, 2. Means second row, second column. This is first row, first column. So the principal diagonal has to have the same number twice. 1, 1, 2, 2, 3, 3, 4, 4. Any question? Okay, now properties. It says two matrices have the same size if and only if they have the same dimension. So if we have two matrices and you're wondering whether they have the same size or not, you have to see, do they have the same number of rows? Do they have the same number of columns? If they do, then they have the same size. If they don't have row, at least one of them are the same, they cannot say they have same size. So same size means same number of rows and same number of columns. On the other hand, two matrices are equal if and only if every element in both matrices are the same element. For example, here, we have two matrices A and B. They have same size and they're equal. They have same size because they have same number of rows and same number of columns. So that's why they have same size. And they're equal because every element in A is in every element in B. So row wise, we have 1, 2, 3 in A. Row wise, we have 1, 2, 3 in B. They're the exact same row vector. 4, 5, 6, we have the second row in A. 4, 5, 6, we are in the second row in B. So they are the exact same two matrices, so they're equal matrices.
What if we had them in different order?
Then they are same size, but not same matrix. They are not equal matrix. They just have same size. Now, two matrices of the same size can be added by adding their corresponding elements.
So 1, 1 goes to 1, 1.
1, 2 goes to 1, 2, 1, 3 goes to 1, 3. So every position, the number you have in every position, you're going to add the position and place them on the same position. Let's do an example. So here we have A matrix 1, 2, 3, 4, 5, 6, row wise. Our B matrix is 7, 8, 9, 10, 11, 12, row wise. So we are finding C matrix by adding A and B matrix. So we can add, because A and B, they have same size. What does same size mean again?
Same amount of rows, same amount of columns.
Good. They have same number of rows and same number of columns. So when we add the corresponding position. You take 1 and you add with 7. You put it on the first position.
So that means you can only do subtraction and addition if they have
Same number of rows and same number of columns.
and you just add the corresponding positions.
Exactly.
Okay.
So here we have 1 plus 7. Then you go to the next position. In next position is 2 in A and 8 in B. So you put them together. 2 plus 8. Then you go to the third position. Go ahead.
When it comes to like the function of the bar, like do you also
All of these are coefficient matrix. We use the bar when you solve a matrix. We are not solving here, we are just combining them together. So third position is 3 and 9. So we add 3 and 9. And we do the same thing for the second one. We have 4 and 10 on the first position, 5 and 11 on the second position, and we have 6 and 12 on the third position. So you add position by position, put them on the corresponding position. So what do you have? Column wise, tell me the answer. 8. We are going row wise. Okay, 8, 10, 12. Second row. 18. Perfect. This is our C matrix which we got by adding A and B. Now you go ahead and do the next one. Find your D matrix by subtracting your A matrix from your B matrix. The D matrix is B minus A. So can B minus A? I want to check the fingers. What? Just for fun. Today's 15, 9/15. Park. Jose. Tenzin. He never showed up. Mehrab. Come on. Kenyan. Bora. Today is also absent. NG. 1.
isn't there?
Probably she dropped because right now I have only 1. Chuyan. Now. Jackson. Christian. Emmanuel. I noticed you haven't done any homework yet. What's the reason? Say it louder. Why? Did you forget or what?
The first one, just a second.
I'm going to open the second one till Wednesday. Make sure submit second one and third one.
I am done.
Good. So submit the third one tonight and submit the second one by Wednesday midnight. Homework is important, very important. It's 15% of your grade. Gregory.
Here.
Where? Yeah. Abid. Origin. What? No. Come on, what's wrong with you guys? Ethan and Elsa. Our star, Elsa. Elsa, you know, my first class has few female students. So if you want, you can start the class from 5:30. If you want.
No, I wouldn't work at that. Work during that time. What's that?
Well, that section there, are you just teaching one other section?
Yeah. One starts from 5:30 to 7, 5:30 to 6:45, and you guys are 7 to 8:15.
If I come back, can I not come to this class?
Sure.
When does that one start?
5:30.
Okay.
And the room is big. I have only few students. So if you all of you want, you can actually come at 5:30. I don't have to be here. Do you have a class? All right.
Yeah.
It's nice. Getting out of here early. Yeah. And then what? Then you're gonna have like just me with at your last period.
True.
You can watch your.
They also come less.
Can I attend on Zoom?
Of course not. You have to be here. I want to see your faces, guys, and have a conversation. But to be honest, I would love to have Zoom classes.
Yeah.
Instead of having 2 days in the week, we can have one Zoom and one.
This one hybrid, please.
I cannot because I have to be here anyway. And I have to be here anyway because my other class have a blind girl. So I have to be here for her. So I'll ask her if Zoom class is okay with her. Then we can have one Zoom class and one in person. Our life will be so much easier.
Wouldn't Zoom be easier for her anyway?
I don't know.
Because they get like
I'll ask
they
her.
get like the reader.
She can't see anything at all. Like,
No.
it's
It's like the
completely.
live reader.
How can she read?
Braille.
No, like online, how can she read?
Yeah,
Here, at least she can hear me.
get that translator when she can't hear you online.
She can hear me online, true. Yeah. She's actually pretty smart, you know. All these metrics, she did it in her head, and she gave me the answers. I was like, wow, impressive. Yeah. Like matrix is all numbers, but she actually kept track of each number, the position. So we did addition and multiplication, and she did it in her brain. I was like, wow.
Maybe does the abacus now.
Yeah. She's amazing.
Do you know if she's in the CS?
Yes.
She is?
Yeah, she's forgot her name. No,
Her name is Maisha.
Aisha, yeah.
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 She's very smart.
She's
Very smart.
Here?
I don't know. Okay, what's the answer for B minus A?
All the positions are 6.
All positions are 6. Perfect. So 6, 6, 6, 6, 6, 6. Okay, so let me get rid of this. The next property says sometimes we have to use zero matrix for convenience, sometimes. But if we add or subtract with zero matrix, it doesn't change anything, just like number. 1 plus 0 is same 1. So if you have a matrix and you add a zero matrix, it's the same matrix you have. That doesn't change anything, adding or subtracting a zero matrix. The next one says, if you want to multiply a matrix by a scalar, you have to multiply element-wise.
Yeah.
So you go element by element.
So scale. So
You have to scale each element
Oh,
by the scalar.
So it is like with each separate number divided. I mean, multiplied by half, negative half.
True.
It's
me-
just a constant.
Hmm?
Each multiplying the matrix by a constant.
Constant. Right. So here you have a matrix is this, and you need to find -1/2 A, means multiply your A matrix, the entire A matrix by -1/2. It means you multiply your element by -1/2, by -1/2, by -1/2. So you go element by element, and then you multiply each of them by your scalar. So who can tell me the answer? Let me erase this. 1 second, 1 second. Okay, go ahead. -1/2, -3, -4, -1, 7, -6, 2, 5, 7. Do all of you agree? Did he make any mistake? Is he good? Good job. Yeah. Dash elimination is when you're trying to solve your matrix. Here you're not solving, we're just combining all the coefficients. Now, this question is from your homework. It says, verify the scenario. Are they true? Are they false? The first one says, if you add A and B matrix and then multiply that by 3, do you get 3A plus 3B? Do you? The next one says, if you have 5A, can you split your 5A into 3A and 2A and then add them? Does it work? The last one says, if you multiply your matrix by 6, is it same as you're multiplying by 2 and then you're multiplying by 3? Is it true or false?
What homework is this from?
It will be in the next homework set. So I'm going to assign you homework points too. So from here, with my other class, I did B. With you, let me do C. We are going to verify that 6 times A will be same as you take 2A and you multiply by 3. So C, our left side says find 6A. So these are A matrix. Who would like to give me 6A?
6, 12,
6, 12,
18,
18,
24,
24,
30.
30, 36. So these are left side 6A. Now you're going to verify if you multiply 2A by 3, do you get the exact same thing? That means first we need to know what is 2A. So let me write, this is left hand side. And now I'm going to work with right hand side. Right hand side. So first we're going to find 2A. Who would like to give me 2A? 2. And then 8, 10, 12. Now we are going to see if you multiply this 2A by 3, do we get the exact same matrix at 6A?
Yeah.
So tell me, what do you get if you multiply 3 with this matrix? 6, 12, 18. 36. Are they same?
Associative.
Yes. Same. So we just verified the left side and right side are same. Hard, right? Hard. How come you're late, Kirk? What happened?
No, life. Life.
Life? So you're saying I don't have a life because I'm here? I'm tired.
You're getting paid to be here.
Ha, ha.
I'm not making any money.
And you paid to be here.
Uh,
So who has more loss? Who is getting paid or who paid to be here?
I go for free.
Real. That's why you don't want to be here. I wish. So we added, we multiply by a scalar, and now we are going to do real multiplication. For multiplication, there is a condition. But before that, some application where we use the multiplication is when you are trying to find your cost function or your cost for your business. If you're a businessman, you want to know what is the total cost. You can easily figure that out by your inventory matrix, multiply by your cost per item matrix. Whatever you get, the result will give you the total cost. It is true. And also, there is another scenario. If you are softball team, what do you call them? The guy who helps them?
Manager?
Manager?
Equipment manager?
Equipment manager? Probably. So if you're equipment manager and you want to ask for budget for your softball team, you can easily find your cost by multiplying your team's expenses and then ask the dean officer someone to give you the money. And then you can use matrix multiplication here. Instead of solving one by one, you can make two matrices, multiply them, you get the result.
That's what they do next time.
How?
Yeah, Excel does everything for us. So that's why you need to know how to do multiplication, addition, subtraction, all these things, so that you can code and tell your computer that do everything for us.
This is Excel.
And that's why linear algebra is important, because in order to do your coding, you need to know how to solve something. Coding is basically the math, but in very details, and you're telling the details to the computer, and computer does everything for you. That's why I don't do the coding. Like, I can do math, but telling the computer to do everything for me, I have no idea. Anyway, so multiplication. There is one requirement to do matrix multiplication, and the requirement says there is one condition. The condition says whatever matrix you're multiplying, the left matrix and right matrix, they have to have same amount of column and row. The left matrix, the number of column in the left matrix have to be same as number of rows on the right matrix. Sorry. Yeah. Number of column and number of row, they have to be same. Remember, it's a condition. Condition start with C. So your left matrix has to have column equals your right matrix of the row of your right matrix. So we're going to tell you here. First, name your size. What's the size of your A matrix?
2 by 3.
Huh?
2 by 3.
2 by 3. So this is a 2 by 3 matrix. And now what's the size of your B matrix? Row by column. 3 by 2. Now the condition says in order to multiply A and B, so A is on the left and B is on the right. So A has to have number of column same as number of rows in the B. So say R, column and row, they have to be same, the condition. If the column and row are same, then you can multiply two matrices. Okay? So for A and B, can you multiply A times B?
Yeah.
Yes. And if you can multiply, then now you need to know what's the size of your result.
So
Go ahead, Abby.
So what if it like they both have the same rows and columns? Will it still be?
As long as we have column on the left is same as row on the right, you can multiply them. These two numbers don't matter. The requirement, the condition is column on the left and row on the right. So column left, row right. If they're same number, then you can multiply. And when you multiply, the resulting matrix will have a size whatever you have on the left and right. So here we have row 2 and we have column 2. The resulting matrix we have the size 2 by 2. So if the condition fulfilled, whatever remains, that become the size of the results. So here our resulting matrix will be 2 by 2. Okay. So the condition C is CR. Left C, right R. If this is fulfilled, then the results, the product will have row and column. So result is row column and condition is column row. Okay. So if you forget, remember your letters. Condition start with C, that means we need column row. Result start with R, so the size of the resulting product will be row and column, RR. So the next one. What's the size of A? 2 by 3. What's the size of B? Good job. 3 by 1. I know I wanted to write 1, but we can 2. So you have 3 rows, but only 1 column. So it's a column matrix. Can you multiply, AB?
Yes.
Why?
CR.
CR. We can, yes. Why? Because C equals R. Left C, we should say left C equals right R. Okay. If left C equals right R, then we can multiply. For addition, our condition was we have to have same size. For multiplication, we don't have to have same size as long as we have left column equals right row. So a few fun example. Volunteer 1, first volunteer, who would like to do A?
What?
Arjun? Okay, go ahead. Tell me the size first. 2 by 3. And the next one? 3 by 2. So can you multiply these two matrices? Yes. And if you can multiply, you should always state what's the result, the size of the resulting matrix. 2 by 2. Perfect. Volunteer for B.
3 by 2, 1 by 3.
3 by 2, 1 by 3.
They can't.
Cannot. So like no. And it cannot, why not?
It's the row, column, and rows are then.
They're not same. Good job. The next one, C. Three by 2. 3 by 3. Can you multiply? It's not possible. They're not same. D. Go ahead. 3 by 1. 1 by 4. Can you multiply? Yes. That means you have to tell me the result. 3 by 4. Perfect. So we can multiply these two because they are same. And since we can multiply, that means whatever remains, that would be our result.
The resulting side, so
Mhm.
these two outside.
The other ends. So you look at inside, if the inside are same, then our result is the outer one.
It's called an operand.
Outer.
Oh.
So inner and outer. Okay, I have 4 more. Next volunteer. People who did not answer anything yet. Emmanuel, you did the previous one. Okay, never mind. Let me ask Elsa.
2 by 3 and then
Hold on, let me write. 2 by 3,
by 3.
2 by 3.
You can't multiply them.
Can or cannot? Good, cannot. Why not?
Left column is not equal to right row.
Perfect. Okay. Abid. F. 2 by 2. 2 by 3. Yes. And what's the result? So 2 and 2 is a condition. If it's fulfilled, the result is the outer one. So what's the result? 2 by 3. Perfect. Jackson. 3 by 2. 3 by 3. We cannot. Because these two are not same. That means Jose. You're the last one. 3 by 3. 3 by 2. Yes. Now result will be 3 by 2. So the requirement, the condition fulfilled. So result will be the outer one, 3 by 2. All right. Any question? Emmanuel, no fun. And now we are going to actually multiply. We knew that we could multiply before, but we didn't know how to multiply. So now we are going to learn how to multiply. When we added the corresponding elements, right? For multiplication, we are going to do the same thing. Sorry, I should have the same thing. We are going to do the similar thing, but differently. We're not going to add the numbers in the corresponding position. Instead, we are going to take one row from the left matrix and one column from the right matrix. So row and column. When you take them, we're going to multiply the corresponding position and then add them. Okay? So here, what's the size of the left matrix? 1 by 3. You have 3 columns. And how about the next one? What's the size of the 3 by 1? Can you multiply? Yes, because we have the same number. Good. Our result will be 1 by 1. What type of matrix is 1 by 1? It's just one number.
Is it always?
It's just a number.
Yeah, it's it doesn't have to be.
All right. It's just a number. That means if you multiply row and column, we get only one number.
Would you call it a scalar? Or is it not a scalar?
It's not a scalar, it's a number vector. Number, it's just a number. Emmanuel, not fun. So, since our left matrix is only one row, so we are going to take this matrix, and since our right matrix is only one column, so we take this row and this column, and we're going to multiply element wise and then add them together. So the first position in the row is 1, first position in the column is 2. So you multiply 1 with 2. So let me use different color. First position 1, 2. So you multiply 1 times 2. And then you add the product of the next position. The next position here is 3 and here is 2. Second position, row and column. You multiply them together. What do you get? 12. And then you add the next position. So next position, let me use pink. We have 5 and 6. So you multiply them. 5 times 6? 30. And this is our resulting results. That's our results. So what is 1 times 2? 2 times 12. 14 plus 30. 44. So answer is only one number, 44. And we don't even have to write that thingy, bar, square, because it's a number. So if you want, you can simply put, or it becomes a number 44. Okay. Then you can see 2, 12, and it is 44. Then my answer is wrong. My answer is 48. Wrong. Any question? Andy?
So we just multiply the corresponding
Position and then add them.
We do it one finger.
Of course, we are going little by little. Let's say you have a 2 by 2 matrix. When you multiply 2 by 2 matrix, you take the first row and first column. So row 1, column 1, you multiply the corresponding number, corresponding position, add them. The result goes on the first position. Row 1, column 1. Then you take same row 1, but you go to column 2. In the same math, the result goes on row 1, column 2 position. So you take first row from the left matrix, and you go each column on the right matrix. The result goes row wise in the resulting matrix. Once you're done with all the columns in the second matrix, then you go to the next row, the left matrix. And you do the same thing, and then you put them row wise on the column position. For example, we have 2 by 2 matrices. So what's the result will be? The resulting matrix size?
2 by 2.
2 by 2. So you take first position, first row, first column. The result will be in the row 1, column 1 position. So AB. So 7 times 8 plus -8 times 3. So for now, let me write it out. 7 times 8 plus -8 times 3. That's your 1, 1 position, row 1, column 1. So with the same row, but now you have to go to second column. That will be your row 1, column 2 position. So what do you multiply this time? 7 times 8,
-8.
-8, -4. Add them. But when you multiply, okay, never mind. It's plus -8. So we are done with all the columns in our B matrix. So that means now we are going to go to the second row of the A matrix. So we take the second row because we are done with all the columns in B. Now we have row 2 and we are taking the column 1 in the right matrix. So its position is row 2, column 1. So row 2, column 1 is here. We are going to write that in this position. Row 2, column 1. What we are going to multiply here? -3 times 8 plus 9 times 3. And then our last position, let me take green. You take your second row and you take your second column. Second row, second column goes on the second row, second column position. What do you multiply in this position? -3 times what? Plus 9 times -4. And this is our resulting matrix. So go ahead, tell me what numbers we have. The result. 15, 56. What are you telling me? Tell me the final answer. I don't have space. The final result, 56 minus 3 times 8, 24. What is 56 minus 24? 32, okay. And then you're allowed to use calculator. 49, row wise or column wise?
56 plus 9.
56 minus 24, because -8, right? Use a calculator, guys. You don't have to use your brain. Use calculator. And tell me, is it row wise or column wise?
Oh, it's -8. Yeah, it's plus.
Yeah, that's why we can do this.
88.
88? Okay. Say it louder, I couldn't hear you. 3 and 36. Did you guys do the math correctly? -60? -60 makes sense. Because we have -24 and -36. Good. -60. So 32, 3, 88, -60. That's our resulting matrix. And what's the size of this matrix? 2 by 2. See, we knew from before it will be 2 by 2. It is 2 by 2. So that's why I multiply 2 by 2 matrix. Now let's do something like this. What's the size for the left matrix?
2 by 2.
2 by 2. And the right matrix? 2 by 1. Can you multiply them? What will be the result? Go ahead, try it. Do the multiplication. And it's 2 by 1. Means you're going to have 2 rows, but only 1 column. So it's a column matrix.
So for the exam, scientific calculators are allowed. Okay, yes, that'll be useful.
2 and 14?
3 and 14 you did mentally already. Almost correct. Almost, but not quite.
Oh, it's -2 and 14.
Did you do the math mentally or you're looking at the solution here? Which one?
What do you mean, looking at what solution?
Okay, never mind.
I don't even have my notebook out. -2, 14.
Yes.
Yeah, okay. I forgot about the negative on top. Or 4 times -2.
Mm-hmm.
I got -2.
10 is not correct. Equals to 6 plus -4 times -2. First row
Both columns.
column. So tell me, what do you have?
So for I have 14,
So 3 times 2 plus
4.
4 times -2. That's your 1 position. So you have, this is your result. So you have the first one, 1, 1. Now give me your 2, 1 position. What do we have for 2, 1 position?
3 times 2 plus -4.
3 times 2 plus -4 times -2. That's our second position. So we have 12 minus 6 and 6 plus 8. Not 12 minus 6, sorry. 8. 6 minus 8. Come on. 6 minus 8, we get, and 14. So these are 2 by 1 position, 2 by 1 results. So row, column,
We multiply each number in the row by.
each number in the column, and then you add the result.
Okay, I get it.
So it's a sum of the product. Sum of the product of the position. Would you like to try 3 by 3? No?
Okay.
Okay, then that's simple to them. So Wednesday, we are going to start by 3 by 3 multiplication. And then we are going to do what? Transpose and properties. Not bad. If you want, you can try this at home.
Forget the idea that matrices are going to work this exact same as like shapes with like the both dimensions. Like I remember when we were like with after transformation, how we want to transpose and like
Exactly, matrix is same thing.
same exact thing. Okay. But there's going to be transformation.
And the transformation is like whatever we are doing. If you multiply by a number, it becomes bigger. And then if you add them, you go somewhere. So you're transforming the position to a different position.
Okay. Is there going to be like reflections and all that? Or? Okay.
Reflection is when you multiply by a negative.
Okay.
So goodbye, everyone. Have a good night.